Okay, the next problem I'll look at is exercise 17C, problem 4e. So let's look at exercise 17C. Okay, I've lost my pen. Okay, there we are. Exercise 17C. Make sure we just get that down. So it's 17C, problem number 4e. The function we are given is y is equal to x squared minus 4 over x squared, and the point that we're given is 4, 3 on 4. Okay, so that's the x, that's the y coordinate. Okay, so what we need to just be careful about is we don't get too confused over what this means. This is just the x and y coordinates that we are given. Okay, again, we know that the gradient is given by the first derivative, the gradient of any curve, so we have to find dy dx for this of this function. That's something that we don't know, and when we first look at this, it does look like it's a little bit complicated, but let's simplify it and we'll find that really it is a simple function to differentiate. So simplifying this, what this will now look like, let's just expand this out. We can say y is equal to x squared on x squared minus 4 on x squared. Okay, this is no different from this function here. It is exactly the same thing. I've just separated the two components and kept the x squared at the bottom. Okay, so now we have those that cancel, giving us 1 minus 4 on x squared. Okay, and we can also now call that 4x to the minus 2, remembering that 1 over x to the n is equal to x negative n, just as a reminder. Okay, so now that we have y as that, we can differentiate that quite easily. Okay, so if we now go dy dx is equal to, bring the 2 out the front, or the minus 2 out the front, so it should be minus 2. Okay, over there, minus 4 that we had before, x minus 2 minus 1 equals 8x minus 3, which can then be represented as 8x to the power of 3. Okay, the point that we have is 4. That's the point on the curve. Okay, so what we need is the x value for that, and substituting the x into dy dx gives us 8 over 4 cubed, giving us 8 over 64. Okay, once we have that, we know just by simplifying that gives us 1 over 8, which is 8 over 64. I think that's the answer.